Hi everyone, it's Christina, and in this video we're continuing the Edexcel A-Level Mathematics Paper 1 from 2018. This is question 4. So let's have a look. In this question we have a curve y equals 2 ln of 8 minus x, meeting the line y equals x at a single point x equals alpha. For part A, we want to show that alpha is between 4 and 3. Okay, so first we can probably mark alpha on our diagram because it's a point of intersection between the line and the curve we're given. So this is our y equals x line. This is our natural log curve. So alpha is going to be this point here. Okay. Now, usually what we would do is we would solve for a point of intersection. You should be quite comfortable doing that. So we would substitute in y equals x into our y equals 2 ln 8 minus x, and then you just solve for x. However, that's not quite what this question wants because it's saying that we just want to show that alpha is between 4 and 3. We don't want an exact value for alpha. So if I actually go through the first step or two of how we would solve for an exact value of alpha, that will kind of give us the key to unlocking this part of the question. So let's write it out. So let's write out y equals x subbed in to this expression. So that's going to be x equals 2 ln of 8 minus x. Okay. If I move the x onto the right-hand side, I would get 0 on the left, and I'd get 2 ln 8 minus x minus x. Now, again, it's important to realize we are not solving for x. So instead, what we want to do to show that alpha can lie in this range, we're going to express this as a new function. So we're going to write a new function f of x is equal to 2 ln of 8 minus x minus x. Then what we're going to do is we're going to investigate the points 3 and 4. So what we're going to do is we're going to check what will f of 4 give us. So that's substituting the value of x equals 4 into our new function. And then we're also going to look at what does f of 3 give us. Okay, so f of 4, what's that going to be? So that's going to be 2 ln of 8 minus 4 minus 4. And then f of 3 is going to be 2 ln of 5 minus 3, like that. So now what you want to do is compute each of these. So you can put them in a calculator. I should have written this as ln of 4 there. And so what do you get? So I'll write it down here, f of 4. You should get, these are not nice numbers, but f of 4 is approximately minus 1.23. So that's to 2 decimal places. And then f of 3 is approximately positive 0.22, also to 2 decimal places. Okay, so if we think about what this means, we're saying that when x is a value of 4, so imagine alpha stretches to get a value of 4, because we're showing that alpha lies within this range and it doesn't actually take the values of 4 and 3, right? It's saying that when we input the value of 4 into our function that comes from solving for the intercept of our curve and our line, we're getting a negative number. And then when we compute for x equals 3 into that same function, we're getting a positive we're getting a positive number. So there is a sign change here. And we can see that somewhere between these two values, we will reach 0. So between f of 4 and f of 3, we're going to get a value that should be f of alpha, which equals 0. And so we know that due to this sign change, we have a continuous function, and alpha must lie between 3 and 4. Okay, so that's not a typically routine question. You do have to think about it a little bit. I think if you consider how you would find the intercept first, you can then go from there. Okay, so now let's have a look at the second part of the question. So the student uses the iteration formula that we have here in an attempt to find an approximation for alpha. So using the graph and starting with x equals 4, determine whether or not this iteration formula can be used to find an approximation for alpha. Okay, so we want to see if we can use this iteration formula, and we need to justify it by using the graph, starting with x of 1, which is 4. So what we want to do here is we want to draw a cobweb diagram. So I'm going to rub out this just in case it confuses us. But for part B, so this is working for part A. For part B, we want to draw a cobweb diagram. Whenever you're looking at iteration formula and you're expected to use a diagram that they give you or the graph that they give you, typically you want to draw a cobweb diagram to justify why you're using the iteration formula. So if you start at x equals 4, what you're going to do is you're going to draw a line from your x equals 4 value, and you're going to stop where it touches the first graph, okay, or the first curve in this case. So we're going from x equals 4, we're going all the way up, and it first hits the natural log graph. So that's where you first stop. Then what you want to do, well, to draw this cobweb diagram, we've gone vertically, so we've gone up along the y-axis. Now we need to go along the x-axis. So the only way we're able to go for us to actually hit another line is to the left. So we're going to go to the left. And then we're going to stop when it hits the next line. So it's hitting our y equals x line there. So just be really careful how you draw these. So it's hitting there, and we're going across here. We hit our y equals x graph, and now we're kind of going to do the same thing again. So the only way for us to go is up here, and then it hits our natural log curve. So then we stop there, and then we repeat the process again. We're going to go across along the x-axis now, and it hits the y equals x curve. And then, of course, once it hits that, we'll go down, and that is hitting our natural log curve there. And then we can kind of stop there because it's going to get a bit harder to see that if we continue. So we've drawn a cobweb diagram here, and we can very clearly see that it's spiraling inwards. Okay, so from the cobweb diagram, we can see there's that inward spiral. So it's converging to a single value. Okay, so we can, in fact, use our iteration formula here, which should give us our approximation for alpha, and we've just justified it using a cobweb diagram to show that in fact this is converging to a single value because we can see that it's spiraling inwards. Okay, so we'll continue on in the next video looking at question 5.